Hello, I'm Haseeb Akhtar from Ericsson.
And I'm Toby Ford from AT&T.
And we're going to talk about an optimized control plane for workload at the edge. Toby?
All right. So today in the telco world, we have this new problem that we're trying to address. With the adoption of 5G, we're going to have to address densification and putting out nodes in many locations, many more than what the cell tower base stations are at now. We also have to deal with other new things, like with the acquisition of DirecTV and our new focus on satellite delivery of content. We have to have a new type of box at everyone's house. We're trying to deploy new types of CPE devices and new types of, for both customer and for enterprise, and we're also having to deal with IoT workloads. So this presents the possibility of having a lot of unused resource out at the edge. How do we manage that? So today in our environments with OpenStack, we have large data centers that have thousands of servers in it, and we use tens of servers to manage it and run the OpenStack services and the SDN controller and our eComp services into. Those tens of servers, as we scale down and have less servers, when we have 10 to 100 servers, a few racks of equipment, we can get that down to a minimum of 3 servers for clustering reasons and availability reasons and all the various carrier grade needs. Now, how do we go less than that? So if we have a deployment of 1 server, like in this room or in your house, and I want to virtualize some part of it and use it to get full utilization, what do I do? What do I run on that? So we have a few options that way with OpenStack. Obviously, you could run an OpenStack like you do on DebStack. You could run it entirely on that 1 server, and then you have the workload along with it. And that's okay, but it doesn't provide a lot of the aggregate benefit of centralized services, or it can be a lot of overhead. And a lot of the problem that we have with the ratio of control plane to resource has to do with just economics. We want to make sure that it's minimized, that ratio. Ideally, we'd be able to deploy in large data centers tens of thousands, if not 100,000 servers with 1 control plane. And in a small site, we'd be able to go to the opposite direction, have as minimum a deployment as possible. So one possible thing is just having smaller deployment like DebStack, or what I'm proposing is an alternative in this option 2, is the possibility that we have a distributed model for Nova, where we assume there's going to be latency between the Nova services and the resource being managed. And then we actually have some level of distributed management.
So Toby, you mentioned that in the small, in small cases, the number of servers could go down as low as 1 or even less, right? And the sites that you have deployed last year and continue to deploy it in AT&T, you have some examples of that as well, I assume?
Yes, exactly. So just if you take VoLT or the boxes we use to deliver AT&T fiber, or the boxes that we're putting into your house, your DVR or the residential gateway, these are things that are examples of what I'm talking about.
Okay.
Yeah, so another dimension to this problem that we're exploring with an edge deployment is how do we insert this into the developer lifecycle of, let's say, a residential gateway or of a DVR or of any of these types of functions. We want that same experience that we have making websites, where I can do my work and be able to push it into the cloud as a part of my version control process, like you do with a Heroku or a Cloud Foundry. So in this model, in this example, a developer is working on the RG software on his laptop, and then he can move it into the cloud and do the requisite testing and regressions that are needed to validate that it works and it performs well. And then you can move it on to the next step, where you actually push it out to the many locations, thousands of locations. This process is enabled by, and what we've been exploring is the use of containers to do that, to create that real portability out to the edge. In the end, the customer gets a lot of value out of it, because we can then change things on the RG or whatever it is similar to what happens in my Tesla, where I can get an entirely new OS. When the next time I drive it, though, all the screens are new.
Okay. So basically then, we're going to show a demo, and I'm showing a use case for that. And this use case shows how IoT devices can communicate in a secure manner by using Apsara container platform that is integrated with OpenStack. To ensure IoT security, what we're doing is we're using two different tools here. We're using first a blockchain technology from Containe that is used to secure the content integrity. And then the payload is encrypted so that it cannot be accessed by anyone else but the authorized users. The use case here also shows an edge component, as you see on the left side, the Apsara gateway, to ensure that the data from the IoT devices are securely blockchain signed and encrypted. So once that is done, the Apsara gateway would use a protocol like NATS or MQTT to transmit the secure data into the network over TCP/IP. And then once the secure data is received by the Apsara platform on the receiving end, it is then blockchain signed and decrypted, and the message is then processed by the event management and the rules engine of the Apsara platform to take it to the next place. So this IoT security and the policy component of the Apsara platform would allow, for example, a FedEx truck to drive up to your house, have the garage door open automatically, and then deliver the package inside the garage, and then leave the premise for the FedEx truck while the garage door gets closed automatically. So that's a very a very secure, intensive use case that touches a lot of the areas of security. So what we're going to show in the demo, in this case, we're taking a Raspberry Pi, which will be blockchain signed. The raw data from the Raspberry Pi will be blockchain signed and then encrypted, and then it will go to the Apsara gateway, and which will be aggregated there, and then it will be pushed out to the Apsara platform, where the blockchain will be verified and the data will be decrypted, and then the event is processed by the Splunk based on the event management and the rules engine. So let's watch the demo now.
Hello. I'm going to show you a simple demonstration on communicating with Internet of Things devices in a secure manner. Inside this box, we have a number of IoT sensors, such as acoustic sensors, magnetic stripe readers, barcode readers, fingerprints, temperature, pressure, GPS, and Wi-Fi signal strength sensor. This setup is really a representative of IoT devices that can pump data to Apsara platform that is running on an OpenStack cloud. One of the most critical aspects of this demo is that all of the data sent from IoT devices are secured. The data received from the IoT devices is first encrypted and then signed through Ericsson's data-centric security blockchain mechanism. Once the data is fully secured, it is transmitted through a NATS communication channel over the internet to the Apsara platform. On this dashboard, we show how we receive the sensor reading, in this case the Wi-Fi signal strength sensor reading, and process it with the blockchain signing and verification process along the ingestion pipeline. We receive the raw JSON data payload, as you see here. Then we sign it by using the blockchain signature and embed that signature as a metadata to that payload. Now, when we receive that data on the cloud side on the Apsara platform, before we ingest it, we do a verification against that blockchain ledger. Only after the positive verification, we ingest the data. We also provide the blockchain signature as the metadata for this sensor reading. Apsara has now verified the sensor data and would allow the appropriate event to be processed.
So Toby, we saw the demo.
Yeah, and it's exciting how you can see, you can imagine, like with last Friday's denial of service attack on Dyn with IoT devices, you can see how this is just one step in that process to make the IoT devices more secure.
Yeah, and the thing is that once you put the edge, the control plane management component at the edge, in addition to allowing for the payload security and the content security, just for the proximity of the gateway near the devices allows you to stop this type of rogue attacks right at the root of it. The attacks that are basically spreads by contaminating other servers in the network, such as the DNS server you just mentioned.
Right on. No, and the other part too that's exciting for me is just the demonstration of orchestrating the containers at the edge, making that a possibility for many of the devices I talked about before.
Yep.
All right.
All right. Thank you very much. Appreciate it.